isn't working. We need to find a way to calculate how much power we need.
Maybe if we reposition the photo gates, if we can... Damn it! We must find out some way.
No. The problem is we're changing acceleration. Work is equal to force times distance, and force is ma. But we're changing A. It doesn't work like that. We would just get an average.
Well, let's at least find our average. That'll be a start.
All right. If we had a bunch more photo gates and put them a lot closer together, we could add up the accelerations.
Absolutely.
This computer isn't working. We need to calibrate it.
No, we don't need no calibration.
Look, it's getting late. We need to take a break.
All right, fine. Let's go.
Okay.
2 pan-galactic cargo blasters, my man.
We have to get this to work.
Well, maybe I can be of some assistance.
Fathom, the epitome of non-SIM. It's just what we need.
Help us? Yeah, right. You can't do anything.
You know, you're a very nice asymptote. I think you're in my range. How about you come home and I'll show you my domain?
Thanks, but no thanks, Fathom.
I just wanna be your integral so I can like tangent to your curves, Candela.
What is this integral you speak of?
Yeah, what is that?
Wait. You're telling me that 2 hotshot physicists like you have never heard of integration?
We're all ears, man. Teach us.
Let's go. Ah! So, it's called the fundamental theorem of calculus, the fundamental theorem of calculus. So, if f is continuous on a closed interval, let's call it A and B. You guys still with me here? Nearly.
Yes, Fathom.
And f is the antiderivative of f on the interval then, you guys ready for this?
Ready.
You can take the different limits, a and b, of the closed interval, and you have f of x dx is equal to f of b minus f of a. This is how you can find the area beneath the curve.
So is that action?
That's really cool.
That is amazing.
Yeah.
We could use this to solve our physics problem.
We could use this to get
Right?
the work.
Right?
Yeah, we could. You guys want to see how?
How?
So check this out. So, work, what you guys are trying to find, is equal to the integral of force times distance, right? So, you could turn this into a little differential equation, and you can then say work is equal to the integral of a part of force, so distance times df. So, this little df right here indicates a little part of your force. This is like taking all of your photo gates, putting them closer and closer together so you know exactly how it progresses. And then you can go ahead, you can integrate the function, and you can figure out your work.
Yay!
Wow, Fathom. That is amazing.
I know, isn't it?
What else can you do with this mysterious little sign?
Well, how would you like to know? So, if you guys want to know what else you can do with calculus, let's try another physics problem similar to what you guys were doing. So let's say you have an infinite line of charge. So you take a lot of plus charges, you put them along the line, and you just kind of keep going. You have an infinite line of charge. It goes on forever and ever and ever, much like my eternal love for Candela. So, let's go ahead and we want to measure the charge at some point. So we know that right here we have a distance x, and then we also need this part of the line here, and we'll call that theta. So that's our angle theta. So we want to know the electric field at this point right here. So we can say that, so we have lambda is equal to Q over L. This is the equation of the charge density for the line. So then we can say, well, we have d E in the x direction. Since the y's will cancel, we have the force point in this direction, force point in that direction. They cancel, they go bye-bye, much like Steve and Candela.
Oh.
And so we wind up with the integral of part of dx is equal to the integral of 1 over 4 pi epsilon naught times dq all over the distance right here, which because of Pythagorean theorem we know to be x squared plus y squared, and because the y's cancel over here, all we need to then do is multiply it by cosine of theta. So we can go ahead, we can simplify this, and we wind up with here, we have Ex is equal to 1 over 4 pi epsilon naught times the integral of lambda dy over x squared plus y squared times x over x squared plus y squared to the 1/2, or otherwise the square root of it. So then we keep, and then we have to have limits of integration on the a and b interval. And since this is infinite, we're going to have negative infinity and positive infinity. So we keep on going, and we pull out everything, pull out all the constants, and we wind up with Ex is equal to lambda x all over 4 pi epsilon naught times the integral of dy over x squared plus y squared to the 3/2. And we can take this one more step, put in our limits of integration, and we will wind up with lambda over 4 pi epsilon naught times 1 over x squared times y over x squared plus y squared to the 1/2, evaluated at negative infinity to positive infinity, and we wind up with lambda over 2 pi epsilon naught x direction. That's what you can do with calculus.
Ooh.
Ah,
Wow, that's really cool.
that's amazing.
Can you do that, Steve?
Yeah, can you, Steve?
Well, you know.
We know Fathom can.
So,
Kind of.
Candela, I think you and I had it better than Riemann sum. Do you want to go have a drink?
I think, yeah.
Yeah, let's go.
Let's go.
We would like to ask all of you viewers, we would like to thank you for your participation and for watching this, and we would like to ask you to donate to the Help Steve Get Candela Back Fund. All funds will go to buying flowers and chocolates for Candela, and also for math tutoring lessons. Thank you. Have you seen my beach ball? I think I left it over there.